Yes, sir.
Yes, sir.
Lovely. Okay. Okay. So let's start with kinematics as we always do. First couple of questions you might seem they're familiar. We've done similar questions before, but as we progress, we'll go to some advanced questions as well and some different kinds of questions as well. So as I said, today we're going to talk about kinematics, and we're just going to initially talk about how does one actually go ahead and solve questions. What is what is fundamental to question solving? Because question solving, if you think about it, is a skill in itself. You require lot of basic understanding, and there has to be a set way of going about solving any question. And turns out, yes, there are some broad things that one can do in order to be better at problem solving. As some general things, like always figure out what all is given and literally write it down. So write down whatever is given to you on the top and what is asked, the question itself, the exact value. For example, you're asked to calculate the pressure, so just write P is equal to question mark, so that it always remains in front of you. Okay, what is your end goal? Because that is essentially your end goal, that is the final solution you need. And then once you know what is given, once you know what is asked for, then try to build connections. Whenever you're trying to build connections, one thing to remember, there are many things to remember. First thing to remember is units. Okay, any question you ask, any question that is asked, check the units. Check the units of the options as well, because many a times what happens is that a question will be really really hard. It will be a really hard question if you actually go ahead and solve it, but the options जो दिए जाते हैं, A B C D, you'll have options whose units are different, and you can just check the units and at least come to, let's say, A or B can be the answer. So you can eliminate the wrong answers essentially if you check for units. First thing you do is check units. Second thing you do is check the number of variables. Check the number of variables. Any question that is asked to you, any question you have to do, after checking the unit, after seeing what is given, after seeing what is asked, check how many variables there are. Variables will include what is finally asked. So, for example, P, pressure will be one of the variables, and variables will be everything else apart from given. Essentially, whatever is given. Apart from that, everything else that you will need to solve it will be variables. Once you have number of variables, let's say the number of variables turn out to be n. N is some value, 2, 3, 4, number of variables. Then check how many equations you have. Check the number of equations. So now equations can be, for example, the question is about Newton's laws of motion. So you have a car which is standing and it's moving at some velocity or some acceleration. So acceleration is a variable, velocity is a variable, distance is a variable, time is a variable, until unless they're given in the question. And what are the equations? Equations are things which essentially connect these equations. What your ultimate goal should be in any question is to match the number of equation to the number of variables. So if there are n variables that are remaining, so you need to find n equations. You need to find n equations. Once you found n equations and you have n variables, you can solve that system. For example, you have two variables and two equations. So for example, x is equal to 2y and x equal to 3z, 3y. These two are different equations, right? So these two are essentially giving you two different graphs. So one is the graph which goes like this and the other is the graph which goes like this. The solution to this two equations, so essentially when one is asking you for the solution, you're solving for what is x and what is y. So for these two graphs, the intersecting point will be only one point, and that will essentially tell you the value of x and y. So here in this case will be 0, 0. So your answer will be x equal to 0 and y equal to 0. But at the end, that is what you have to do. You have to calculate the number of equations, which should be equal to the number of variables. Lovely. And then you can have more complexity in the sense that you can have linear equations, you can have quadratic equations, you can have cubic equations, you can have differential equations, but these are still equations. If you have n variables, you need to find n equations, whether it be differential equations, whether it be linear equations, whether it be any kind of quadratic equation, any kind of equation, you just need n equations. Okay, that is how one proceeds with solving any question. Okay, so let's move ahead and let's actually go ahead and solve some questions. How do I remove this? All of this would be from here. Oh no, from here. No. Okay, first question. Two forces. You're given the forces in vector form. Um, are acting on the same object. So you have one object on which these two forces are acting. The x component and y component of the forces are given, obviously. For what value of b will the magnitude of the resultant force be minimum? The magnitude of the force will be minimum. So again, first write down what all is given, second what is asked, and then equations and solution. So go ahead. I'll give you like, this should not take more than 1 minute. Minus 12. Yes. Yes, yes. Yash, would you like to tell us how did you go about doing this? There are patches on the screen. These are your uh, chat things. Wait, let me close this. Okay, I hope there are no more patches. But then now I won't be able to see your comments. So that's something. I can just keep it on this side.
Excuse me, sir.
Yes, go ahead.
So there is some sort of blue square coming in between the
Yeah,
question.
that's the chat thingy. This thing, right? This is moving right now.
Yes, sir. Yes, sir.
This is the chat, essentially chat box. So I mean, I have to see your chats also. So I don't know. How do we just ignore that right now? Okay, so what is happening here? You have a body on which there are these two forces acting. Let's say F1 and some other direction F2. These are the two forces that are acting on this same object. If the magnitude of the force of the resultant force has to be minimum, so essentially let's start from the start. What is given? Two forces, F1, which is essentially 3 I cap plus B J cap, and F2, which is 9 I cap plus 12 J cap. One way of seeing it is just straightforward. Okay, to minimize the resultant force, what you need is to minimize this B, right? So the sum of this and this F1 and F2 has to be zero in to minimize the force. To do that, you just put B is equal to minus 12, then this will essentially cancel out with this. That is one way of seeing it. But if you want to go ahead, literally actually do it. So how would you go about doing that? Well, you will say that the total force should be just equal to F1 plus F2. So this will be 3 plus 9, which is nothing but 12 I cap plus 12 plus B J cap. Yeah, okay, that is the resultant force. That is something that is expected. Now, the magnitude. Now one needs to calculate the magnitude of this resultant force. The resultant of any, the magnitude of any vector is just the x component square plus the y component square, the square root of that. So the magnitude of this is nothing but square root of 144, which is 12 square, plus 12 plus b whole square. Now this has to be minimum. So one thing you can do is you can literally just take a derivative and put that to zero in order to see when this is zero. Or again, the easier way for this to be zero, since this is positive, the smallest value will be when this term, the second term, first realize this second term cannot be negative, right? Because there is a square here, there's a whole square here. So this term cannot be negative. The smallest value of 12 plus b whole square will be zero, right? The smallest value of this whole thing will be zero. So when is this zero? This is zero when b is equal to minus 12. And that is your final answer. Okay.
Excuse me, sir.
Huh, go ahead.
Sir, but we have to get a value for B specifically, right?
Yes,
So,
b
and
specific.
this is whole square. So, if we put the value as minus 12, it
Hmm.
would be 0 whole square.
Yes, zero whole square, which is
Wouldn't that
zero,
make sense?
which is essentially the minimum value of 12 plus b whole square, right? Because 12 plus b whole square is always greater than equal to zero because there's a square here, right?
Yes, sir.
So the minimum value of 12 plus b whole square is zero.
So, what if we put a minus 11 over here? So,
If
that
you
would
put
be 1
minus
square,
11, then you will get a 1 square, right? Which is 1.
which is also
I
greater
agree,
than
which is
0.
greater than 0, but 1 is not the smallest thing that 12 plus b can be, right? The smallest is 0.
Yes, sir. So, B would be minus 12. So, automatically we'll get under root 144, which would be equal to 12.
Yes, which is equal to 12. That's the
And sir,
minimum
if we
magnitude,
put
right?
and sir, if we put b as 0, that would be 12 square. So that would be 288 under root, which would be
Yes,
greater than
which is
140.
more, right?
Yes, sir.
And we need to
So
calculate the minimum.
yes, sir. So wouldn't the answer be minus 12 for b?
Yeah, that is what I said, right? B is equal to minus 12.
Oh, sorry.
Lovely. No problem. Okay, let's move ahead. Second question. An object moves from the origin from point A to point B and finally stops at point C. So, how should the figure be? So, let's draw the y-axis and draw the x-axis. Uh, that's fascinating. Okay. Yes. So origin is O here. Object moves from the origin to some point A, then to move to some point B. Um, we know that OA, whatever this angle is, OA distance, this is 5 centimeters. Then it travels to, well, the angles are also given actually. From O, okay, so it's actually on the other side. It's not on this side. So let's remove this. Okay, the angle is given to be 120 degrees. So that's 90 plus 30. So that should be around here somewhere. So it's essentially traveling from O to A and it's traveling 5 centimeters. Then, then it turns 180 degrees and goes to B. So it's going in this direction. Now it goes in which direction? Somebody? It goes right, left, upar, niche.
Sir, opposite direction.
Opposite direction as in back.
Yes, sir.
Yes, sir.
It goes back to
Yeah, the
here.
same line.
Yes, to here, which is the point B, which is essentially 6 centimeters. So this, all of this is 6 centimeters, and then it takes a 250 degrees turn and goes to C. So 250 degrees would be what direction here? ऊपर
Sir,
नीचे आगे पीछे.
towards
Huh?
the third quadrant. Sir, towards the third quadrant.
Towards the third quadrant. So 250. is essentially 180 plus what, 70, right? It's 180 plus 70. So it will be 180 degrees plus somewhere here, right? It will go something like this. And it's traveling, oh, that's a long distance. It's traveling to point C, which is 10 centimeters. So this distance is 10 centimeters. Find the distance from O to C. You need to calculate this distance. Go ahead. Square root of 101. Yes, Abdullah. What's up? Any doubt? Root 101. Can you explain the last question again? See, last question, what was happening was a straight way to see it is that you have one vector जिसका पूरा दिया हुआ है which is some constant plus a constant, some constant in the x direction, some constant in the y direction. There is another one which is also constant in one direction but a variable in the other direction. And you are asked, okay, what should be the value of the variable such that the resultant is zero, right? So the resultant to be zero, 21 centimeter. Sure. So the resultant to be zero, essentially what you need is b plus 12 to be essentially equal to zero, because that's the minimum value that b plus 12 can have, because it's a whole square, right? So it's a positive quantity. So hence the lowest value that it can have is zero. And what is the value of b when it's zero? Yes, the resultant should be minimum. See, if the resultant should be minimum, what was the resultant that was coming out to? 12 square plus 12 plus b whole square, right? For this to be smallest, this cannot be negative, right? This cannot be negative because there's a whole square here. So the minimum value of this will be zero. So the minimum value of 12 plus b is zero. So for this minimum value to be zero, what do you need? You need 12 plus b to be equal to zero. This implies b should be equal to a minus 12. Does that make sense? Lovely. Root 99 units, root 101 units. Interesting. Okay, let's think about this. So you're essentially given a triangle whose two sides you're given. You're given one, this to be 1 centimeter and this to be 10 centimeters. BC sides to be BC to be 10 centimeter and OB. So OB is 1 centimeter, essentially given, right? This OB given would be from OA and AB, because OA is 5 centimeters and this is 6 centimeters. That's going back, so that's just 1 centimeter. And BC, you have 10 centimeters. Now, what about the angle? Well, we know that this angle is 30 degrees because this initial angle was 120 degrees from O to A. So this is 30 degrees. Lovely. If this is 30 degrees, then what is this angle? Well, this angle is supposed to be 90, and all of this is supposed to be 180. So this angle plus this angle should be equal to 90 degrees, and hence this angle should be 60 degrees. Okay, this angle is 60-degree. Lovely. Um, you need this particular angle here. Okay, this is 30-degree line. Here you have This is 30, 120, 180, and 250. So this is actually 70 degrees here. This particular thing here. Why is this 70 degrees? Because okay.
That was
So, huh?
180 plus 70 equals 250.
Yes, 180 plus 70 is equal to 50, because you were go traveling in this direction first. This after moving to B, so you're going in the negative this direction. Negative 120 degrees, so 120 plus 180 degrees, which is essentially 300 degrees that you were going towards.
Sir, I have a question.
Okay, and then you go 250 degrees again. So 250 degrees would be 180 plus 70. So this angle has to be 70.
So
Lovely.
why can't the C be on the other side?
Why can't the C be on the other side? Uh, because of the angles it's making, right? Or on this side, you're saying.
Yeah.
Because see, it's making 250 degrees, right? You were traveling in this direction and then you move around 250 degrees.
So, but how do we know that he'll rotate?
Clockwise, it's always clockwise. If you're rotating, you're always rotating clockwise. Remember
Okay.
that. Always clockwise rotation. Make sense?
So this is anti-clockwise.
Huh? Oh,
Yes,
sorry,
sir.
anti-clockwise. Oh, yes, yes, yes. Always anti-clockwise rotation. Your
Okay, sir.
your so angle whenever you're calculating in a graph, it's always anti-clockwise, right?
Okay, okay, sir.
That's why. So okay, so this is 70 degrees. Now we have a triangle whose essentially this third length you need to calculate. Okay, how would you go about doing that? Okay, lovely. So how do I move this? Okay, I cannot move this. This Okay, so what kind of a triangle is this? So let's draw this triangle here neatly. Uh, so we're essentially drawing this triangle here. Um, okay, actually I drew it ulta, but that's can be rectified. So it would be like this and like this. Now do you get the figure? So this is 70 degrees from this angle here. This point is B, this point is C, and this point is O. This is 1 centimeter, this is 10 centimeter. You need to find out this side. Okay, to find this out, let's cut this into perpendicular. Well, no, let's call this point some point D. We know that these two are right angle triangles because this obviously has to be 90 degrees. Right angle triangles means, you have 70 degrees here. So you can do the sine and cos. You can use trigonometry to essentially find out what this distance is and what this distance is. Once you found out this distance, you can use Pythagoras theorem to essentially, because you'll know this distance and you'll know this distance, so you can use Pythagoras theorem to essentially get the third distance. So let's do that. So what's the distance from B to D? Well, that's just 1 centimeter and cos 70 degrees. Lovely. What's OD? Well, that's 1 centimeter multiplied by sine 70 degrees. Lovely. So you now we know what distance is and what this distance is. What we want is OC, and we know that using Pythagoras' theorem, we have OC square is equal to OD square plus DC square. So what is OD square? Well, OD square is just cos square, sorry, sine square 70. Sine square 70 plus DC. Uh, DC is 10 minus sine cos 70 degrees whole squared. So, okay, I'm going to write it on the top now. So what is OC square? Well, this is just sine square 70 plus 10 square, which is nothing but 100 plus cos square 70 minus 2 cos 70 times 10, 20 times 70 times 10. Lovely. Okay. So sine square and cos square would give you 1. So this is just 101 minus 20 cos 70. Cos 70, well, cos 70, if you want to approximate, you can
0.66.
approximate it as cos 60. It's close enough to 60, but will be slightly different than 60, cos 60, but you can approximate it by that value.
Sir, it's
What, huh?
0.63.
Cos 70.
Yeah.
Okay, 0.63. Lovely. So you just multiply this. What do you
So
get?
we'll be given such values, right?
Huh?
We will be given such values, right?
Yes, yes, cos 70. You'll yes, if you're getting a question in which you need the value of cos 70, you will be asked for cos 70. You will be given cos 70. Yes. But right now, obviously, calculators are good. So 0.63 into 20, well, that's 6.3 into 2, that's 12.6. So 101 minus 12.6, which is equal to what? Um, hmm, I have a point 4 here.
88.4.
80, 80.4.
88, 88.
Huh?
88, I said.
88.4. Yes, that sounds lovely. 101, yes. Okay, so 88.4 centimeters is square root. Yes, yeah. So this is OC square. So for OC, you need to calculate the square root of 88.4 centimeters. Anybody? Calculator, please. Something near 9.2. Yeah, this looks out. It's close to 100, so it will be. I mean, it would be less than 10. It will be around 9 point something only, 9.2, let's say. So it's around 9.2 centimeters. Lovely. So all we did here, we first of all we drew the diagram, then we figured out what exactly is the triangle that we're working with, drew the triangle again, named all the sides as it was in the question. So you have O on top, you have B here as B was here, and you have C here as C was here. You have 70 degrees here, and BC was given to be 10 centimeters. So all of this was 10 centimeters, and all of this was 1 centimeter. What I did was, if you're given a triangle like this, you can always imagine a perpendicular dropping from the top point to the bottom, and you say that this is 90 degrees. And then you can just use cos and sine in order to find out the perpendicular and the one that is below the base. Yes, yeah, the base, and then if we have this distance and this distance, well, we can, if you have this distance, then we can calculate this distance here because it's this minus this, and then we can just use Pythagoras' theorem at the end in order to calculate what the final value is. Lovely. I hope all of this is clear. So, and let's move down. Oh, Abdullah, yes, what is the question? Doubt. Angles. Okay. Okay, we can go through the angles here again. Okay, actually, let's do it again. Let's see the angles properly again. Um, you have the x-axis. You starting from the origin, then you're moving 120 degrees. So 120 degrees is in this direction. Then you move around 180 degrees. So if you're moving in this direction and you're turning 180 degrees, so you start moving in the opposite direction, right? And you start moving in the opposite direction up till 6 centimeters. So this was 5, this is 6 centimeters. So here, and then you move 250 degrees. So you were moving in this direction, and then you move again 250 degrees. So 250 degrees is essentially 180 plus 70, right? So 180 degree is essentially you go back to this direction here, and then you add a 70. So it will be around somewhere less than 90, right? So it will be somewhere here. And this is 10 centimeters. And then you need to find out what this OC distance is. So this is essentially the triangle that we're taking. So since we already know that this is 180 degrees and this total has to be 250 degrees, so this has to be 70 degrees, right? So 70 degrees, right? Then you essentially build this triangle. It's the same triangle here where O is this, B is this, C is this. You put a perpendicular. This is 1 centimeters. This is 70 degrees. So this distance is just cos 70 degrees, right? And this total distance is 10 centimeter. So this distance is just 10 minus cos 70. And that is why we put a minus sign there. And we subtracted this because it's what you essentially get by using this triangle is, and here you get sine 70. So you have sine square 70 plus 10 minus cos 70 whole square. And because of this, the two AB terms has a minus sign. So you have a minus 20 cos 70. This is a 2AB term, which will have this minus. So whole square karo na, a square plus b square plus 2ab, and there's a minus term, so a square plus b square minus 2ab. That's why you have a minus term. Okay, I hope all of this is clear. Can we use angle law? You can use whatever law you want. Yes, at the end I use Pythagoras' theorem because in this triangle here, if I know the height and if I know the width, I can use Pythagoras theorem to essentially calculate the hypotenuse, right? That is essentially what I did. Okay, let's move on to the next question. Let's move on to some proper kinematics. Okay, this question is such that an ant from ant hill, an ant runs from the top of an ant hill in a straight line, so that its velocity is inversely proportional to the distance from the center of the ant hill. When the ant is at a point A, at a distance L1 is equal to 1 centimeter from the center of the hill, its velocity is given to be 2 centimeter per second. How much time will it take for the ant to run from point A to point B, which is at a distance of L2, which is 2 centimeter from the hill, from the center of the hill? So the question is something like this. You have an ant hill. You know how ant hills look, right? You have the thing and you have a hill here, essentially. And the ant is going standing here and it's essentially coming down. And it's coming down such that the velocity is inversely proportional to the distance. Okay, go ahead. Should not require more than 2 minutes. 1 centimeter per second. I think that's close. 1 centimeter. You have to actually have to calculate the time, so it cannot be in centimeter second. But 1 second. Okay, Yuvraj, how did you go about doing this? Tell me, tell me. Okay, so you note down what is given to you. Essentially, the ant is starting from here. First of all, you know is that the velocity will be inversely proportional to whatever distance you are traveling. So let's call that distance x, not d. Let's call it x because it's moving, right? Um, and the velocity is inversely proportional to x. Lovely. So the more the x is, the smaller the velocity. So that's something that is very interesting. Secondly, you're given two distances. Yeah, one distance L1, where you know what the speed is. Okay, so if its speed is proportional to x, this what does this mean? It means that v is equal to some constant c divided by x, right? How do you calculate this constant value? Well, you're given that at L1 is equal to 1 centimeter, V1 is equal to 2 centimeter. So from here, that this means that if x is equal to 1, your V is equal to 2 centimeter per second. If x is equal to 1 centimeter. Lovely. So this implies, let's put in the value, 2 is equal to c by 1. This implies c is equal to 2. Now you have the value of c. So this implies your v is equal to 2 by x. Okay. Now, what it's asking you is how much time it will take for you to get to from L1 to L2. Okay, there are multiple ways of going around doing this. One way of doing it is if you do the speed, one can think of it as a differential equation. So you can write V as dx by dt. So you can write this as dx by dt. And you can take the x on other side, integrate on both sides, and put the proper limits. You will get what essentially you will get will be the answer. But what another thing and another smart thing that one can do is actually look at what the graphs actually looks like. So let's see what the graph actually looks like. But the graph between what? Well,
Velocity and time. Velocity and distance.
velocity and distance. Yes, we can plot a graph between the velocity and the distance x here. But won't it be more useful to actually just plot 1 by v with x? Because my 1 by v is proportional to x, right? So all you'll have will be a straight line.
Yes, sir.
Lovely. So essentially, you will have a straight line on which you're moving in this graph. So always think about plotting graphs also. Before you plot any graph, think about what you're getting. If you're getting something like a weird shape, always try to plot a graph in which you get straight lines because you know how to work with straight lines, right? स्ट्रेट लाइन मेरे को पता है कि उसका एक पॉइंट अगर मेरे को पता है, मेरे को दूसरा पॉइंट पता है, मेरे को स्लोप निकाल सकता हूँ और मैं कहीं पे भी कुछ भी निकाल सकता हूँ, राइट? You know what
Yes.
the equation of this should look like. So that's why this is easier. Okay, so you are moving from L1 to L2. Okay, so L1 is here and L2 is here, right? If you need to calculate the time, can you see from the graph? Can you directly read out what the time should be from the graph?
The area of the graph.
Yes, time will be nothing but the area under this curve will be essentially the area of this triangle per plus this rectangle. How do you see that? How do you know that this is going to be true?
Because it will be 1 by v into x, which is x by v, which is time.
Yes, exactly. So what is the area giving us? Uh, कहाँ गया ये? Here. And here you are. Okay, so what is this graph between? This graph is between 1 by v and x. What does the area essentially signifies? It
Time.
signifies integral of the function multiplied by dx, right? What is the integral of dx? Yes, yes, that is what I'm doing exactly. So what will the area be? Area will just be the integral of the function which is 1 by v multiplied by dx. So you're essentially what you're doing is you're dividing it into small sections of dx length, and you're integrating from point L1 to point L2. This area, if you see what the dimensions of this is, you notice that velocity is meter per second and distance is just meter. If you cancel this out, what you get is just second. So whatever your area will be in terms of seconds. Now, how many things do you know that are counted in seconds? The only thing you know that is counted in seconds is time, right? So this has to be time. The area that this is giving has to be time because those that is what the units are saying. So units are essentially helping you here also to essentially just tell you that this is going to be time. Okay,
Sir,
huh?
can't we directly say that time is equal to distance by speed?
Yeah, sure. Time is equal to distance by speed. Or you can also say that, but you do realize that time that this is not a linear, as in it's not just speed. The speed is also changing, right? The speed is changing with distance. So you'll actually have to do an integral rather than actually because it's not linear, right? It is 1 by x that it is depending on. So this won't really work. This is only works when your acceleration is a constant, right? If your
Yes.
speed itself is changing with distance, then you cannot use this formula, right? Okay, so what is the area of this shape? Well, we know these 2 points, L1 and L2. We know this point, the velocity of v, this is 1 by 2. Uh, this is 1 by 2 because v1 is 2 centimeters and this is the inverse of v1. So this is 1 by 2. And the value here of v is what? Well, you have 2 by 2, which is 1. So essentially, the value of 1 by v is just 1. Okay,
Yes.
so now we have a triangle. This is 1 centimeter and this is 2 centimeter. So let's just calculate the area of this. What's the area below? Well, it's just distance, which is 1 multiplied by, so time essentially is equal to 1 multiplied by, what's this, half, plus a half into base into height. What is base? 1. What is the height? Well, it's half again. So it's half plus 1 by 4, which is nothing but 3 by 4.
Why is the height half
Height of what?
the triangle?
Of the triangle, because this is going up to 1, no? From half to 1.
अच्छा वो half है वो 2 लग रहा है सर वो this chart is just
1 divided by 2. It will be 1 by 2, right? Because you're plotting 1 by v. You're not plotting v. You're plotting 1 by v.
okay. The chart box is hindering the view.
Sir,
Yes, go ahead.
we could solve this by integration.
You can obviously solve this by integration, but notice what you are doing by integration is just calculating this area. So if you're given just squares and triangles, it's just actually easy to just solve the area, right?
Yes, sir.
So that's the only thing. You can obviously do it through that also. Nobody's stopping you. But one thing remember, one thing when you're always solving any problem, obviously there are multiple ways of solving problems. But what the goal is essentially is to figure out the simplest way or the most efficient way to solve any problem. There are many ways of solving any problem. But what is the most efficient way? If you keep your mind towards the most efficient way, a lot of windows will open. Because what essentially happens is that you will find techniques to solve certain equations that will be very useful in solving other questions. These techniques are essentially what we are trying to learn here. For example, this technique here, if this function wasn't inversely proportional to x, and as in it wasn't a very good integrable function, for example, a weird x times log times and divide by 1 minus x, which weird function hota, so it will still be essentially given by some simple figure, and then it will be useful in that case. Okay, let's stop wasting our time and move on to the next question. Yes, go ahead. Somebody has a question. Abdullah, you have a question. Okay, the rest of you, a ball is dropped vertically from a height d above the ground. It hits the ground and bounces up vertically to a height d by 2, neglecting subsequent motion and air resistance. Its velocity v varies with height, as so you need to plot the graph between the speed and height h. हमें ट्रायंगल की हाइट कैसे पता चले? हमको ट्रायंगल की हाइट ऐसे पता चली कि, so essentially you were starting here, this was L1, the speed was V1, right? Then you moved to here, which is L2 at V2. हमने इस लाइन की इक्वेशन निकाल ली थी, क्या थी इक्वेशन? 1 by V is equal to some constant, sorry, V is equal to some constant divided by X. I've written it ulta. So our equation was V is equal to some constant, constant was 2, that is what we calculated, divided by X. So V1 is when L, this is 1 centimeter, this is 2 centimeter. Let's put in the values, no? V1 is equal to, is equal to 2 divided by 1, so it's 2 centimeter per second. And V2 is just 2 divided by 2, so it's 1 centimeter per second. So this value here, since we are plotting 1 by V, so we are getting 1 by V1, which is 1 by 2, and this is 1 by 1. So the distance between this and this is a half. Lovely. Okay, this question here. Any ideas? कैसे plot होना चाहिए? What is happening is you have the floor and you have a ball which is starting out at height D, and then it hits the ground. It goes up back to height D by 2 and then goes down again. V
It should be
proportional.
a V graph. V.
Yeah, what we need to plot, I'm coming to that, how the V varies with the height. Okay, this is constant acceleration. You
Yes,
give
sir.
some acceleration g. So velocity or height के लिए we have, for constant acceleration we just have 3 equations, right? The Newton's 3 equation you have: v is equal to u plus at, s equal to ut plus half at square, and v square minus u square is equal to 2as. Correct? Which one will be useful here? The third one, right?
Yeah, V square minus U square 2S.
Lovely. So if you're starting from rest, we are starting from rest. So whenever it's going down, as soon as it starts going down, your v square minus u square should be equal to 2a. So let's call this distance x. Sorry, z. Z
The
because
GH,
huh?
for 2GH.
Yeah, 2gx. Yeah, 2gz. Your initial velocity is 0. So you have v square is equal to 2gz. If you want to plot z with v, the what is happening in v, so how does this look like?
A parabola.
A parabola, lovely. But what way is the parabola? Is it going up? Is it going down? Where does it start, first of all? Well, it starts at v is equal to 0. Then it's going up or down.
It will go up.
It is going up.
because the slope is increasing
Okay, till when will it go up?
till it reaches height equals 0.
Yes, height equals to 0. So z जब तक d नहीं हो जाता. Since we're measuring z from here, so where z is equal to 0 is this, and this is equal to z is equal to d, right? तो हम उल्टा measure कर रहे हैं. Z is equal to 0, z equal to d पे आया, तो फिर ये रुक गया. Then what happens after that?
इसके बाद
Then
सर एक ऑप्टिव स्लोप बनेगा नीचे को.
then it comes up, but your equation changes. What does it equation changes to? Well, whatever your, it's essentially your end. So when it's coming up, your final velocity now is going to be 0. You have some initial velocity. Let's call this, whenever it comes down, it has some velocity, it strikes, and upper b, it's moving at some other velocity. Let's call it u. So, and we know that the final velocity, so that it goes up to the top, is 0. So what do you have? You have v square minus u square is equal to 2 minus 2 g z. But z is also decreasing, right? So this is also a minus z here. So that's why it makes it a plus z here. And what you have v is equal to 0. This implies u square is equal to minus 2gz. How does this graph look like? It also looks like a parabola, but what direction does it go? Does it go like this? Does it go like this? How does it go?
So the
Option
second,
1 or option 2?
the second one.
Second one. But does it start here or start somewhere else? It will start somewhere else, right? Because
Yeah, it starts
it
somewhere
is
else.
losing some energy and hence it's going only half speed. Well,
I think
it
from origin
will
it will start because
it will start at some other speed and then it will go down to okay, tell me what it should be. This is not true. कहाँ पे जाएगा?
सर ये वेलोसिटी origin से start करेगा ना वापस because velocity वापस 0 होगी.
Velocity वापस zero थोड़ी होगी. End पे zero हो जाएगी. Yes. So essentially you're starting from here
Sir,
and going
velocity should be
there.
negative.
You're going like this. So
Yeah.
initially you
हम
went from
we
zero.
can consider it as two cases. Second case में free fall consider कर सकते हैं ना इसको.
क्या चीज?
No, sorry, मैंने उल्टा बना दिया.
Okay, so essentially, what is happening is it's losing some energy, and it's losing enough energy so that it just goes up to d by 2. So what should be the initial velocity if it's going up to d by 2? Well, u should be equal to minus 2g
D by 2.
d by 2. So minus gd. Hey, so you notice that you're getting u as negative. So it's not starting here. It's actually starting on the negative sign. It's actually
Sir,
starting here.
that was u square ना.
Yes. Oh, yeah, u square is equal to minus 2g and equal to u d by 2. Oh, you're measuring niche super. That's why. Okay, okay, okay. So you'll get a positive sign here. So yes, u is equal to square root of gd. So you know g, you know d. So essentially, this value will be square root of gd, and then it'll come back to the origin. So essentially, that is what the equation looks like. It goes up, and then the speed changes, and it comes back to the origin. Because this is distance z, right? And z is measured from top to bottom. When it's going from bottom to up, there will be a minus sign because of that. So it's moving from d to
Sir, I have a question,
d
sir.
by 2, so it will be minus d by 2. the distance that is moving.
First case, the graph you drew that इसमें height 0 थोड़ी ना हो रही है.
Oh, it's going back to d by 2. It's not going back to 0. Yes. You're right. So essentially what is happening? You have z in this direction. You're moving up like a parabola. Um, lovely, lovely parabola to some height, so to some z, which is d. You reach this point, then you change your speed, and you essentially come back to d by 2. So it's essentially like this. Sorry, you're not coming back to the same point, you're coming back to d by 2. Okay, does this make sense? Does this graph make sense? Yes, no,
So
maybe.
Velocity high पे हो जाए when the velocity.
Huh?
सर ये d कहाँ 0 मतलब हाँ d भी तो 0 होना चाहिए.
D zero थोड़ी हो रहा है, D खाली D by 2 तक जा रहा है ना. It's just
नहीं
going
नहीं.
up till here. That's what the question is saying, right?
At that instant when it is
हाँ,
bouncing, जब वो बाउंस कर रही है सर जमीन से टकरा के ही तो बाउंस करेगी तब
हाइट
हाइट.
मैंने ऊपर से ली है. Z is equal to 0 ऊपर है.
ओके
सर
ओके.
सर
हाँ,
सर ये जो है दूसरा वाला सर वो नीचे से नहीं आना चाहिए because when the ball is gaining height it should have negative.
good thought. Yes, and that is how we learn, by doing mistakes. Should it be like this or should it be like this? People confirm, one or two. You are supposed to be solving the question. Is it one or two?
Second.
सेकंड वन.
Second one. So, what is your final graph look like? It's going up to a certain velocity, and then from the negative, it's going back to d by 2.
यस सर.
If again it does it again, then it will go like this, and then come back like this, and go like this, and come back like this.
यस सर.
Lovely. It's a beautiful graph. So now you guys, I think, understand how these graphs are made. Okay, I need to check the graph for this. Yes, sorry. So how does the displacement graph look like? Where is the this variable? Annotate and plot. Lovely. So it's essentially going from top to the bottom. Given the graph, you have velocity dependence on displacement. So essentially x. Um,
सर इसमें बताना क्या है.
you need to tell me which of the following graphs.
But where are the followings?
I'm telling you. I'm telling you. Just give me a second. Shit. Um, okay, I messed up. Um, So now this should work. So screen share, desktop. Okay, so these are the four options. Can you see the four options?
Yes, sir.
Lovely. What was the initial graph that looks like? Well, you have what you have? You have velocity and displacement going down. Yes, like this. Okay, should it be A, B, C, or D?
C.
C. Anybody else? किसी और के पास कोई और आंसर है?
A.
A. Why should it be A?
सर वो V और T होना चाहिए ऊपर जो आपने वो किया है.
Okay, so essentially what is happening is that the velocity is, yes, this is D. Your velocity is continuously decreasing with the displacement and it's linear. So, okay.
Acceleration constant होना
So
चाहिए.
essentially what do you have is you have V is proportional to minus D. This implies V is equal to some minus constant times D, right? This is displacement, so let's call it X, not D. Let's call it X is proportional to minus x. So v is proportional to v is equal to minus cx. So what is your acceleration? Acceleration is just this essentially. Hmm, acceleration versus acceleration. Yes. So what is okay. So you need essentially need to differentiate on both sides to get acceleration. dv by dt is equal to minus c dx by dt. What do you get? You get acceleration is equal to minus c times your speed v, and your speed is already given to be minus c times x. So put in the value. What do you get? You get c square x. So a is equal to c square x. It's linear.
Linear तो C.
Hmm?
नहीं not C, not C, not C.
So which one is it? It is linear and it is going up. So it has to be A, right? Yes, no, maybe.
Yes sir, yes sir.
It has to be
Yes,
A.
sir.
Moving on. But the only thing is, you whatever constant you'll get a constant here as well. This constant will be negative. So essentially, there is some initial acceleration that this is starting with. You can actually plot it like this also. So it will be a linear function here. Lovely. Is this clear?
Yes sir.
V is proportional to minus D because that's what given in the graph, right? Minus X. It's literally going downwards. So it's proportional to minus X. As X is increasing, velocity is decreasing. That is essentially what was given there. Okay, next question. Hey, why is this not happening? अच्छा, clear यहाँ से. Okay, next question. A toy car is moving on a closed track, which is curved. It's so.
सर वो क्वेश्चन नहीं दिख रहा.
कौन सा क्वेश्चन लिख रहे हो?
मतलब नीचे ऊपर स्क्रॉल नहीं किया ना, वो चार्ट आधा आधा दिख रहा है बस.
क्या चीज?
सर
So
प्लीज
that
स्क्रॉल.
patch आ रहा है बीच में.
सर स्क्रॉल उसे ऊपर करो क्या.
Okay, sorry. Why is this not going? What is this nonsense? Yes, is it gone now?
Yes sir.
Lovely. Okay, so what you have is you have this. एक तो यार मेरी ड्राइंग इतना बुरा है माशाल्लाह से. Lovely. So a toy car is moving on a closed track. So this is what the closed track looks like. The radius of this semicircle, both the semicircle is equal, and it's given to be 1 meter. So both these radius are 1 meter. I need to give you the graph of the variation of speed. Okay. Um, just give me a second. I need to go here. Oh, okay. I need to draw this. So you're starting at some speed 0.125, and you're going up to 0.250, and you're coming straight, coming down, and you're going up, going straight, and you're coming down, and up, and going straight, and then dot dot dot. This is a point two. This is point two plus pi over two. This point is two plus pi. This point is 4. Point is 2 plus 3 pi by 2. And this point here is 4 plus 2 pi. And so on and so forth. Lovely. Okay. Okay, can you see this graph here? Yes. So the track is essentially given to you, and this is how the essentially the velocity moves. Found everything. Lovely. So you have two straight lines, which essentially form the straight part, and you have semicircles here, which is the radii are given to be 1 meter. This is what the graph looks like. So the y-axis varies from 0.125. Uh, yes, so this is essentially speed.
Sir, what do these axes represent?
This is the speed. Yeah, this is the speed v, and the x-axis is essentially the distance you're traveling. So you're traveling from you start from here, for example, then you move 2 meters. So all of this is 2 meters. So you move to 2 meters in a constant thing. Then you move 2 plus pi by two with decreasing and then increasing. So this is what essentially the graph looks like, and this is essentially distance. And what you need to calculate is the time required for the car to complete 1 lap. So that will be equal to 6 times k, and you essentially need to find k. So go ahead. Yeah, this is s equal to 0. So how would one round look like? Well, this is the straight part. It's going from S to this point here. Then it starts moving in a circle, which is essentially this point from here to here. Then it moves 2 meter again, which is back, then moves along a circle, and it ends at this point. This is one lap.
सर
Huh?
दो adjacent x कोऑर्डिनेट के बीच में कितनी डिस्टेंस है?
दो adjacent x coordinate के बीच में
सर
कितना
सर आप
distance
बस
है?
तो ये 2 के बाद क्या लिखा है मतलब?
Okay, I'll write it again. This point is 2. Center point is 2 plus pi by 2. Last point is 2 plus pi.
ओके ओके सर.
Then this point is 4. The center point is 2 plus 3 pi by 2. And the final point is 4 plus 2 pi.
सर आपने क्या बोला एक लैप कहाँ तक का है?
क्या चीज?
सर आपने क्या बोला कि ये ग्राफ में एक लैप कहाँ तक का?
एक लैप essentially तुम्हारा यहाँ तक का होगा ना, 4 plus 2 pi, इस वाले पॉइंट तक का.
ओके
Because it's essentially going straight, circle, straight, circle. That is one lap. So you're going straight, you're going circle, straight, and then circle. Okay, answer. Answers quickly. कोई thoughts? ना टाइम नहीं लगना चाहिए. Okay, let's think about this. What is happening from distance 0 to distance 2? Essentially, the upper part of the relay of the run. Well, this is the distance we know is 2 meters. The speed it's traveling is constant. Since the speed is constant, so you can easily calculate time that is required to reach point. Let's say this point is A. Well, what is the time required? Well, that's that speed, which is equal to 0.25 into speed is equal to distance upon time. What is distance? Distance is 2 divided by t. So this implies t is just 2 by 0.25, which is nothing but 8 seconds. So it will take you 8 seconds to reach A. Now it's going from A to B. A to B, but it's a negative slope. So what do you have? Well, you have a straight line with a certain slope and you're moving along. Your graph is between V and X. So what do you have? You have dV by dx should be equal to final point. So y2 minus
सर
y1 divided by x2 minus x1,
सर
right?
प्लीज कैन यू रिपीट आपने क्या किया? s equals 0.25 equals 2 by t.
क्या चीज?
सर आपने कैसे किया ये s equals 0.25?
Just writing speed is equal to distance upon time. स्पीड कितना दिया हुआ है? 0.25 इस पार्ट में फ्रॉम ओ टू ए, लेट्स से. स्पीड कितना दिया 0.25, डिस्टेंस कितना दिया हुआ है 2, टाइम निकालना है, स्पीड इज इक्वल टू डिस्टेंस अपॉन टाइम, दैट्स ऑल आई हैव डन. Now from A to B, your dv by dx is y2 minus y1. So y2 is 0.125 minus 0.250 divided by x2 minus x1. So that is 2 plus pi by 2 minus 2, which is what? Minus 0.125. What's half of that? And the 2 cancels out. You get pi by 2 here. So you get 0.25 divided by pi with a negative sign. So that is dv by dx. But what you need is the time, right? How do you get time? Well, doing that, if you just think about it, just think about it for a second. Any time you have dv by dx equal to a constant here, right? 0.25 upon pi. How about you just multiply and divide by dt on the left hand side? What do you get? You get dv by dt is equal to, sorry, multiplied by dt by dx is equal to minus 0.25 by pi. You're just multiplying and dividing by dt, right? Well, you have dv by dt and dx by dt is again v. So you have another v here is equal to minus 0.25 by pi. You can take the dt on other side. So you have 1 by v dt is equal to minus 0.25 by pi times dt. Sorry, dv hai ye. So what is v? So you just integrate from point A to point B, right? So integrate on both sides, point A to point B. How much time should it take? It's going from 0 to t, and v velocity is going from 0.25 to 0.125. Well, what's integral 1 by v? Well, that's just log v from 0.25, 0.125 is equal to minus 0.25 pi t. What's the value of this? It's just minus something, right? It's just minus log 2, right? So let's remove all of this nonsense. What do you get? You get log, so ln 0.125 divided by 0.25 is equal to minus 0.25 divided by pi times t. This implies t is equal to pi log 2 divided by 0.25. And in the question, you're given pi log 2 to essentially be 2. So let's just put it as 2. So 2 divided by 0.25. So it's another 8 seconds. So it takes another 8 seconds to reach A to B. Now, similarly, you can go from B to C. This will also take you 8 seconds.
सर इसका आंसर कितना आ रहा है?
किसका आधा?
नहीं, इसका आंसर कितना आ रहा है कह रहा हूँ.
इसका आंसर 8 सेकंड ना?
नहीं पूरे उसका.
पूरे उसका. So would be 8 plus 8 plus 8 plus
नहीं,
8.
I mean क्वेश्चन का आंसर कितना आ रहा है? K equals what?
हाँ, एक सेकंड. 1 2 3 4 5 6. There are 6, right? So it will be 6 times 8, the total time. So the answer is just 8. K is equal to 8.
Okay sir.
Make sense?
Yes sir.
सर वो हमने पाई लॉग 2 का
Question में दिया हुआ है pi log 2 is equal to 2. It's actually approximately equal to 2. Put it in a calculator, you will see.
सर लेकिन यहाँ मतलब log फंक्शन तो नहीं आ रही है.
हाँ, क्या
सर यहाँ log कहाँ आया?
log कहाँ से आया?
log कहाँ आया क्वेश्चन मतलब आंसर लिखते हुए?
क्या है ना log, ये log ही तो है ये.
अच्छा ओके, वो वहाँ नजर नहीं पड़ी.
1 by v के इंटीग्रल से है ना, 1 by v इंटीग्रल dv. This will give you a log, which is essentially this, which is essentially log 2. This is minus log 2, right?
सर
हाँ.
सर अगर हम इस कंडीशन में एवरेज वेलोसिटी कंसीडर कर लें इसकी तो उसके बाद सॉल्व करें तो विल
एवरेज वेलोसिटी निकालोगे कैसे इसकी? वो निकालना ही बहुत बड़ी काम है पहली बार.
we'll take the total time and
टोटल टाइम ही तो निकालना है वो तो पहले निकालना ही वही है so essentially to solve the question you will solve the
sir,
question.
but yes, got it, sir.
Lovely, lovely, lovely.
सर
Okay,
मैंने
so I
पूरा
think we should stop here because already खाली 2-3 मिनट ही बचा है and कोई doubts है तो पूछ सकते हो, otherwise let's meet tomorrow or day after whenever we are meeting next.
Thank you, sir.
Love.
thank you, sir.
You're welcome, you're welcome. We'll continue these things tomorrow. Take care, bye. Quitting now.